Good Monday morning to everyone, or maybe it's Tuesday evening. I don't know when you're going to see this, but welcome back to Algebra 2. Today we're going to be working on features of graphs, things like domain and range, horizontal, vertical asymptotes, increasing, decreasing, what's the end behavior, that type of thing. So I'm going to go through kind of how to look at the graph and make that determination. Sometimes certain graphs always have the same feature, so that answer will just repeat itself depending on the function itself. And other times it changes. So I'm going to try to give you some things that are always and then how to look for other things. Just a reminder, we will wrap this unit up this week. Tuesday is our last day of this unit, so we'll be graphing on Tuesday, and then we'll review Wednesday, and we'll have a test on Thursday. I had my day wrong. It'll be on Thursday, the 7th. So Tuesday will be our last day of instruction, and then Wednesday is a review, and then Thursday is a test. Something I highly recommend is to look back at the quizzes that we've taken on Delta Math, because a large portion of the test will be on Delta Math, and so it's going to be the same type of questions and the same type of opportunity with no video. It won't have an example, that type of thing. So if you look back at the quizzes, you'll get an idea what the Delta Math portion of the test will look like. All right, so let's take a look at an exponential graph. So Tuesday you're going to actually be graphing this, but today you're going to answer questions. So the Delta Math is going to give you a drop-down menu of certain answers, and so you get to pick and choose what your answers are. And so what I'm going to try to do here is give you ways to answer the exponential graphs. So exponential graphs basically look like this. Sometimes if there is an x-axis reflection, then it would look like this. But they basically all kind of look like this. But anyway, one thing you'll notice about an exponential graph is that its domain is always going to be negative infinity to positive infinity. So when you get to the Delta Math, and that's one of the answer choices, like, hey, what is the domain of this graph? The negative infinity to positive infinity will always be the answer to an exponential graph. Now, let me I'm going to write down the basic function. Y equals a b x minus h plus k. And so you should be familiar with the a, h, and k. Okay? The next question you would have to answer is about an asymptote. Now, it's going to ask you if it has a horizontal or a vertical asymptote. Well, here with the exponentials, it's always horizontal. So these are things that are always constant on an exponential graph. Now, and also, it will ask you, is it x equals or is it y equals? So again, an exponential graph will always be y equals. Now, how do you answer the asymptote itself? Well, that's the letter k. I mean, you're not actually going to write down the letter k. But the vertical shift, whatever this number is that's hanging out outside the parentheses of the exponential function, is what the horizontal asymptote is going to be. So these are the same number. Okay, so if there's a 4 hanging out up here, then the horizontal asymptote is y equals 4. So whatever that value is up here is what the asymptote is going to be. All right, so domain for an exponential will always be negative infinity to positive infinity. However, the range will not. When you go to answer the range, it'll give you, again, it's going to give you a drop-down menu. And so when you answer in your range, you're going to include the horizontal asymptote number. So when we look, let's just take a look at this right here. So on this graph, there would be a horizontal asymptote that came through here like this. So this would be the horizontal asymptote. And so the range of this, remember, we do range from bottom to top of the graph. And so down here, we include the horizontal asymptote. And so on this graph, when you look at this, this crosses at -5. So the range for this function would be -5. That's the bottom of the graph. And then the top of the graph, how far up does this graph go? Well, as you can see, there's an arrow right here. So that's going to infinity. So when you do your range, it's going to ask you, to a drop-down question for range. The horizontal asymptote number will be one of the choices. Okay. The only thing you have to do is be careful. Is that horizontal asymptote going to be the top of the graph, or is it the bottom of the graph? Okay, so you have to be careful with that one. So it may try to trick you and flip this. So you just got to be aware. The other questions it's going to ask about increasing and decreasing. So it's going to say something like, so as the domain, as it gets bigger, is the graph increasing or is it decreasing? Okay, so you've got to look at the graph and go, well, this graph, as I go to the right, is increasing. It's going up. Okay, so I'm going to turn this so I can write. This is increasing. Okay, and the bottom graph down here, this one would be decreasing because the y value is getting smaller. So on this one right here, the drop-down menu is going to give you these two choices. It's going to say, is it going to increase to infinity as the x gets bigger, as the domain gets bigger, or is it decreasing to infinity? So this is what it looks like to increase, that it goes up, and this is what it looks like to decrease, that it's going down. The last couple of questions are going to ask you about end behavior. And so the trickiest one is the first question. But basically it's asking about, let me get some different colors here. It's asking about the left and the right hand side of the graph, okay? And this is the toughest part. And I'm going to show you a couple of Delta Math questions. I'm going to pull my computer over so that you can see maybe how to answer this, and I'll give you the best way to answer it. But just to say, as we're talking about the left and the right behavior, and it doesn't, and they are drop-down menu questions, so it's kind of a multiple choice thing. But just to talk about it, it does not answer it as left and right. Okay, the right-hand side is going to say as x goes to infinity like this, and the left-hand side is going to be weird. The left-hand side is going to be, it's going to differ based on what the graph looks like. Okay, so not sure how to tell you that, except you have to look at it, and we'll just have to discuss it when we get there. But the right-hand side here is always going to say as x goes to infinity. And so as we're looking at this, as the x is going to the right, we are going to positive infinity. And so it'll give us a choice to say y goes to positive infinity. Okay. So that's some guidance on how to do an exponential function. I'm going to give you some guidance on how to do a logarithmic function. And then we'll look at a couple of Delta Math problems, and we'll move from there. All right, so I didn't copy this down, but this is a logarithmic graph. It does look a little bit different. I promise they do look different. Here's the two. This is logarithmic. This is exponential. Okay, they do have some differences. What I forgot to write down, or I forgot to cut and paste, is that the logarithmic graph is range is always going to be negative to positive infinity. I'll put some parentheses around that for you. With a logarithmic graph, you'll always have a vertical asymptote, and it'll be x equals. So these things that are in yellow, whether it's for logarithmic or exponential, these are the things that are definites, alwayses, when you're doing these types of functions. And I'll show you how to tell the difference when we get to the delta math, whether it's logarithmic or exponential. All right, so here, with a logarithmic function, it would be y equals a log, parentheses, x minus h plus k, like that. And here, with the vertical asymptote, the x is always equal to the h, which is the horizontal shift. So it's similar but different here, okay? So you have to pay attention to whether you have a logarithmic graph or if you have a exponential graph, okay? Now these are things that you're going to be able to use when you're taking your test on Thursday. So either write them down, print this out, have it ready to go so that you can use it and help yourself out on Thursday. The whole goal here is to try to improve your grades. So do the best you can to use that stuff. Now, as we get to domain, remember that domain is left to right, okay? This time it's going to include the vertical asymptote. So on this graph, it appears that we have a vertical asymptote, let's say VA right there, okay, at -3. So here, the domain is going to include that value. So when we look at this and we go left to right, how far left does this graph go? Well, it stops. It stops right there. It doesn't go any further. So what is that value? That value is -3. It goes to infinity. So again, when you get to the drop-down menu and you're doing the domain, this will be an option. So look for that vertical asymptote number to match up with the number that's in the domain option. Okay, once again, it's going to ask you, is the domain, as we move to the right, is this graph increasing or decreasing? So this is increasing. This graph is increasing because it is moving up. It's going up. So one that would decrease would look like this. Okay, this is a decreasing version of a logarithmic function. Decreasing. So the question there is it going up forever or is it going down forever? Okay, so that will help you with the increasing and decreasing. And again, this is a drop-down option, so you'll get to choose. Is it increasing or is it decreasing? So it's you don't have to say the values, but you have to say one of those two. That's the option of that question. All right, and then finally, again, your behaviors. Okay, this time, as it moves to the left, it's going to say as x goes to, and you'll use the vertical asymptote number again. Okay, so if you notice, as we move the graph this way, if we look into the left-hand side, do you notice that it stops? It doesn't go past there. So what does it do? Is it going up or is it going down? So this graph goes down. So we would say that y goes to -infinity on that one. And then on the right-hand side, what's the right-hand behavior doing? So x would go to infinity, y would go to positive infinity as well. Okay? All right, so we've reached that point where I want to show you some delta math questions. So I'm going to adjust the computer, get it underneath the camera so that you can see it. It should not be a glare on the computer, so hopefully this will work out okay. So if you'll give me just a second to transition over to that. Hope everybody's doing okay, getting out, doing some walking, some exercising or something. I've been trying to run almost every day. I'm getting there. Just give me another second or two here. Features of exponential graphs. Skills, boom. Okay, so here we go. Let me get you a decent problem here. All right, so hopefully you guys can see this okay. I'll autofocus it for you. Squeeze the picture down so that you can see the whole thing. All right, so first question is going to be, scoop this up so you can see. Is the function f of x, where's my cursor? There it is the function logarithmic or exponential? So how do we answer that? Well, if you look back up in the problem, it'll say log, log, base 3. So if that log is not there, that makes it exponential. So here we have a logarithmic graph. So the first way we're going to answer this is logarithmic. So the function is logarithmic with a blank asymptote. So if you look back at your logarithmic notes always have a vertical asymptote. So the choices are vertical or horizontal. So we use vertical. And then the next question says, okay, is it x equals or is it y equals? Well, logarithmic graphs are always x equals. So x equals, and then we have to put a value in here. So we'll squeeze back up, and we'll look at our notes, and it says the vertical asymptote is h. H is inside the parentheses. So you'll look at this, and you'll say, Coach Scott, there is no parentheses here. So that value becomes 0. Not O, 0. Is that 0? I guess that's 0. All right, so the range of this function, okay? So the range of the function, range of logarithmic graphs is always negative infinity to positive infinity. So you see all these choices, right? Well, there will be a negative to positive infinity choice, okay? And it is blank, increasing or decreasing in its domain. So as the domain, it is this going up or is it going down? So it is going up, therefore it is increasing. In its domain of, okay, so now we get to state the domain. So we said that we will use the vertical asymptote. The vertical asymptote was 0. So the 0 right here, okay. So you'll see right here we have a 0 to infinity as an option. The end behavior on the left-hand side. All right, so this is one of those tricky questions. So as we look at this graph stops. It stops at the y-axis, which is 0. So that means that we have x going to 0. Now, what is that left-hand behavior? Is it going down or is it going up? Well, this graph is going down at this point. So we find the y is going to negative infinity. And the end behavior on the right-hand side is, okay, well, x is going to go to infinity because it goes to the right forever based on that arrow. And now what is it doing? Is it going up at that point or is it going down at that point? It's going up at that point. So that's how we're going to answer each of the questions. We'll hit submit. Yes. Got the green check. We're good to go. So please print this out, save this, write it down, do something. We got a lot of answers filled in just based on this information right here. All right, so let's find an exponential graph. That's not exponential, not exponential. Here's exponential. All right, so with this graph right here, you'll notice that it does not say logarithm in it anywhere here. So that makes this graph exponential. Now, I'm not going to do this one because I want it to have some shifts to it. So let me just skip ahead. Okay, so here we have an exponential graph with a -4 on the outside. Okay, so this is exponential. So what we're going to look for are things that are here highlighted in yellow using K. Okay, I'll bring this back in as we need it. So we're going to answer the very first thing with this function. Where's the cursor? This function is exponential. With a what type of asymptote? Is it horizontal or is it vertical? Well, we have a horizontal asymptote for this graph because it's exponential. Exponential graphs will always have a horizontal asymptote. And is it x equals or is it y equals? Okay, well, it's y equals. It's always y equals. And it's y equals k. K is the number on the outside of the parentheses. So let's look up. You'll see right, let's get the cursor, right here. You'll see a -4 on the outside of the parentheses. That becomes the horizontal asymptote. So we'll come down, where did we go? Type in -4 as the horizontal asymptote, which is going to be a line that's right there. For those of you that are curious what that would look like, there's a line that would be coming right through here, which would be our asymptote. The range of the function is bottom to top. So somewhere in this, we will be using our number -4. But let's look at this, okay? So the function's range is, all right, so we have all these options, and you'll see that there's -4 in there a couple of times. Now it's bottom to top, so this is the bottom of the graph, which is -4. So the -4 is going to come first, and it goes, let's see, -4. It's the only one with -4 first, and yes, it goes up to infinity forever. And is this increasing or decreasing as it's going through the domain? So what we're saying here is, as we go through this graph, as we move from the left to the right, does this graph go down or go up? And this is a graph that is decreasing. This is going down as we move to the right. And so I showed you that right here. Oh, yeah, it looks kind of like this right here. It's decreasing as it goes down to the right. So it's decreasing. And its domain, let's see, what's the domain? Okay, so if you'll take a look at this, exponential graphs have a domain that is -infinity to positive infinity. Oh, let's find that. It's in here somewhere. Boom, there it is. Now we get to the end behavior, which is the tricky part. So, so what it's asking is, I hope you can see this. This is saying, does x go to -infinity? In other words, does it go left forever? Or does it stop at -4? Well, this goes on to the left forever. This arrow right here is saying it goes to the left forever. So that's -infinity. And then what is it doing on the left-hand side? Is it going up forever? Is it going down forever? Or is it stopping at -4? Well, this is going up forever. That's what the arrow says. So we're going up. And the end behavior to the right, which is this side over here. So what's it doing? Okay. So is the x going to the right forever? Or is it stopping at -4? Well, the x actually goes to the right forever. It's not stopping at -4. The y, the end behavior, as we're moving to the right, gets to -4, but doesn't go below that. Remember that we have a horizontal asymptote right here that it cannot get below. That's what an asymptote does. It's a line that the graph approaches, but it doesn't reach. So it does not go down below -4. So this answer and this answer here are actually the same. Okay, so we'll submit that, hit yes, got a big green check, and that kind of wraps up, what it looks like to do the two graphs when you're doing the features as your homework. Okay, so I'm gonna move the computer, wrap this up for you. All right, hopefully everything worked out okay. You saw it okay. There are 8 Delta Math questions. Now, they're random, okay? So you notice that I had to kind of click to get me some exponential graphs. So it's random. It's possible that you get all exponentials or all logarithmics. I can't tell you that it's going to be split even 4 and 4. Okay, you might have 1 exponential and 7 logarithmics. And there's no penalty on these problems because each problem does have a lot of questions like you saw. I wish you guys the best. I hope you're doing well, and I look forward to hearing from you. Have a great day.